We've got an AS trig question for today. As usual, pause now, try and have a go at the question, and I'll get to the solution in a moment. I'm going to start by quickly writing out the question. In first year of maths, we have only two identities. They are cos squared x plus sine squared x equals 1, and tan of x is equal to sine of x divided by cos of x. Which one do you think will be the most helpful here? I think this one. There are no tans around here, and there is a squared in the sine. So this one is the more logical one to go for. Sometimes you can make mistakes, choose the wrong formula, just try again if you get the wrong one. So if we rearrange this, sine squared will be 1 subtract cos squared. So I'm going to put that into a bracket here. Add 7 equals 0. Let's expand the bracket. That seems like a good thing to do. Like this. And then 12 minus 13 will be minus 1. Don't really like this minus, so I'm going to move everything onto the other side, equivalently times everything by minus 1. When you're looking at this, your spidey sense should be tingling because this is a hidden quadratic. Choose whatever letter you want. I'll go for y to be cos of x. So this means that this gets transformed into 12y squared minus 7y plus 1 equals 0. We can then factorize this, use the quadratic formula, or use the calculator, probably. We're going to get 4y and 3y, which means that y is equal to a quarter or a third. But what was y? Y was cos of x. So cos of x is equal to a quarter, or cos of x is equal to a third. From here, we need to find the actual values of x. So what I'm going to do is I'm going to do the inverse cos of a quarter and the inverse cos of a third to get the principal values of x. So using the calculator, cos to the minus 1 of a third is 70.52. I'm going to write down all these decimals. I know there are so many of them, but I want to try and be as exact as possible. And then cos to the minus 1 of a quarter is equal to 75.52248781. But those aren't the only answers for this question, and in fact neither of those answers lie in the range up here in the original question. So I'm not going to bother with the cache diagram because that's not how I roll. Instead, I'm going to draw the cos graph, which looks like this. These two values, 70 and 75, are roughly here and here. Instead, I like to use the symmetry of the cos diagram. So 360 is over here. So I know that if I have to move in 70 going left, then by the symmetry, by the power of cos, 360 minus that will give me another solution. So I'm going to do 360 minus that value. In this case, we get this horrible value. And I'm going to do a similar thing with 360 minus the approximately 70. And we get 289.47122206. Neither of those are still in the range, but that's okay. This is what I like to call primary value and secondary value. Primary and secondary. Once you've got these two, it's only a case of adding or subtracting multiples of 360 until you've got all the solutions in the range. So we take 70.5, we add 360 and keep adding 360 till you've got all the answers in the range. Then you take 289, adding and adding 360 until you've got all the answers in the range. And you do the same thing for 75. Then you do the same thing for 284. It may be that there is no solution in the range. For example, if I take 289.4 and then add on 360, that's too big. But that's where the solutions come from in, say, another question, perhaps when the range is a bit bigger. So I'm going to take that original value of 70.5. I'm going to add on 360 and I'm going to get 430 point all those decimals. I'm now going to take the 75 value. I'm going to add on 360 and I'm going to get 435.5224878. If I add 360 to 284, it's too big. If I add 360 to 289, it's too big. So those solutions will just not count. So the final answer is simply just this value here, 430. Looking back at the question, it wants it to one decimal place, so 430.5. Or this value here, 435.5. Underline it for good luck, and that's a question done for 5 marks. Well, there you have another trig question done. How do you feel about the CAS diagram? Try these questions. Don't forget to put your answers in the comments below, and I'll see you in the next one.